All right, reviewing 10.1 to 10.3. The first section, we're asked if it's arithmetic, geometric, or neither. Number 1, to get from 3 to 12, we added 9. To get from 12 to 27, we add 15. It's not the same number. Therefore, we know it's not arithmetic. Arithmetic is when you add the same number over and over again. Okay, let's try geometric. From 3 to 12, we multiplied by 4. Are we multiplying by 4 again to get from 12 to 27? The answer to that is no. We're not multiplying by 4. So we're not multiplying by the same number over and over again, which is what happens in geometric. So we would say this one's neither. Because it's neither, I don't have to finish the question. Number 2, from 18 to 12, I'm going down by 6. I'll be subtracting 6. To get from 12 to 8, I subtracted 4. So it's not a consistent number, so it's not arithmetic. To check geometric, this one's not as obvious what we're multiplying by, so we can check ratios. So to get from 18 to 12, take the latter of the two numbers and divide it by the former of the two. So 12 over 18, they're both divisible by 6, because I want to simplify this ratio. 12 divided by 6 is 2, 18 divided by 6 is, sorry, I don't know why I wrote 6. 12 divided by 6 was 2. 18 divided by 6 is 3. So I end up multiplying by 2/3. Now I want to check and see if that's consistent, if that's constant. That's what I do for the next term. So we repeat the process. The later number is 8, divided by the prior number, which is 12. Divide them both by 4. I get 2/3. There's some consistency. So yeah, we're multiplying by 2/3 over and over again. So that means this is, in fact, geometric. And then we have to list the next 4 terms. So what we want to do is take the 8, and we can think of it as 8 over 1. We're going to multiply by 2/3. When you do that, multiply straight across. 8 times 2 is 16. 1 times 3 is 3. And that didn't simplify, so 16/3 is the next term. Then we keep repeating. We'll multiply that term by 2/3. So multiply straight across. 16 times 2 is 32. 3 times 3 is 9, so 32/9. Multiply by 2/3 again. Multiply the numerator by 2. 32 times 2 is 64. Multiply the denominator. 9 times 3 is 27. And then do it again. Multiply by 2/3 again. 64 times 2 is 128. 27 times 3 is 81. So I guess I should have also circled geometric. Okay, now find the indicated term, in which the indicated term is the 16th term. That's the end. We're just going to use our formula. Our formula is this. It says a sub n equals a sub 1 plus n minus 1 times d. So I'm just going to plug my numbers into that. So n is 16, so I have a subscript of 16, meaning the 16th term is this. a1, which is negative 18, plus, we know n is 16, so 16 minus 1, which is 15, gets multiplied by d, which is 12. So that's 15 times 12 is 180. Make sure you're doing order of operations. So negative 18 plus 180 is 162. So that's the term we're looking for. Number 4, find the nth term. So we use this exact same formula again. I'm not going to write it again. We can see it right there. We know a1 is 31. I also know what d is. I can see that from one term to the next I'm going down. I'm decreasing, so it's subtracting 14. Those are the only two things I plug in because I'm looking for the nth term. It doesn't specify a specific term. So a sub n equals a sub 1, which is 31, plus n minus 1 times d. Because d is negative, I'm going to put it in parentheses so I understand I'm multiplying by it, not subtracting it. And then I want to simplify this, so I'm going to take and distribute my negative 14. So negative 14 times n is negative 14n. Negative 14 times negative 1 is positive 14. So I'll combine my like terms. So I have negative 14, but then 31 and 14 combine to make 45. So there's my rule. number 5, we're finding the arithmetic means. That means we're trying to find the numbers in between if this is an arithmetic sequence. So what I'm doing, because it's arithmetic from one term to the next, is I'm adding d over and over again. At this point in time, I don't know what d is. But I can see, I'm going to write an equation out of this. I started at 24. I added d. Let's count it 1, 2, 3, 4, 5 times. So I could say I added 5d. And when I did that, took 24, added 5d, I ended up at -1. So it equaled -1. It's an algebra problem to solve. Let's subtract 24 from both sides. Divide by 5. We see that d is -5. Now that's not the answer to the problem, but that tells me from one term to the next, that's what I'm doing. I'm subtracting by 5 over and over again. So now we can fill in the missing terms. So 24, I just subtracted 5, so that would leave me a 19. Subtract 5 again, I get a 14. Subtract 5 again, I get a 9. Subtract 5 again, I get a 4. And then the next term would be the -1. So those are the 4 missing terms in the middle, the 4 geometric means, or arithmetic means, rather. Okay, now find the sum. So use my sum formula. So there's the formula. So the things I need to know what n is, I need to know what a sub 1 is, and I need to know what a sub n is. So a sub 1 is my first term, that's 1. A sub n is my last term, that's the 301. But I don't know what term that is in the sequence. 1 is the first term, 3 is the second term, the third term, the fourth term, but then it goes dot, dot, dot. So I don't know how many terms it skipped, so I don't know which term in the sequence 301 is. So we have to figure that out before I can actually use the formula. So I then go back to this formula we have. I wrote it down under number 3 here, the formula for arithmetic sequence. We're going to use this formula right here to help us figure out what n is. So that formula requires that we know what d is. D is the number we add from one term to the next. That's an easy one for us to figure out. I see that I'm just adding 2. So now let's plug the numbers into there. So a sub n, well, I know what a sub n is. That's 301 equals a sub 1. I know that. That's 1 plus n minus 1. I don't know what my n is. That's what I'm trying to find out. Times d, which is 2. I'm going to distribute. I'm going to go ahead and move this back up now. Distribute my 2. N minus 2. I'm going to combine my like terms, my 1 and my -2 together make -1. I'll add 1 to both sides now, so 302 is equal to 2n. Divide by 2, I get 151. So I can go back, put that up there. So now I have enough information to use my formula. The sum of n, so 151 terms, that's what I'm doing, is adding the first 151 terms together, is equal to n, which is 151, times the first term plus the last term divided by 2. 301 plus 1 is 302. 302 divided by 2 is going to be 151 also. So I end up with 151 times 151. And that is, well, I'll type it in the calculator. I get 22,801. So that was number 6. Number 7. I think they give us everything we need. They give us a sub 1, they give us a sub n, and they give us n. I don't even have to work to find it, so I can plug everything in right away. So the sum of those looks like 10 terms. It's equal to 10 times, first term was 4, last term is 22, divided by 2. So 4 plus 22 is 26, half of that is 13. Times 10 is 130. Now we go to the back page, which I believe is our geometric sequences. Find a sub n. So we've got a formula. I'll write it up here. A sub 1 times r to the n minus 1. So we just plug into that formula. So we know the subscript, we know the 6. So a sub 6 equals a sub 1, which is 800, times r, which is 1/2, to the n minus 1, so 6 minus 1. So that's the 5th power. So I'm really trying to take 1/2 to the 5th power. And so we have a choice to make here, I guess, whether we want to deal with a fraction or as a decimal, and I'll accept either one. If I'm just going to go with a decimal, I just as well plug the whole thing in all at once. So let's do that. 800 times 1/2 to the exponent of, in 6 minus 1, I'm just going to type in 5. Make sure you have parentheses around the 1/2 and the exponent outside the parentheses, though, or it won't work out. And we get an answer of 25. So 25 would be the 6th term in that sequence. Number 9, write a rule for the nth term. It says of the geometric series, that should say sequence there. We're not adding the terms together, so it's a sequence. Sorry about that. So we see our first term. Let's think about what we know. Our first term is -3. What are we multiplying from one term to the next? It looks like I'm doubling it and changing the sign, so I'm multiplying by -2. I don't know what n is. They want me to write the nth term. I don't need to plug anything in for n, so we're just going to plug in those two numbers. So a sub n equals -3 times, do parentheses around your r, the -2, to the power of n minus 1. That right there is the formula. You may not multiply -3 times -2, because -2 has an exponent on it. So there's nothing more you can do to that problem. That was the answer. Number 10, geometric means. So we're saying, what are we multiplying one term by? What are the middle terms of this geometric series? Assuming we're multiplying by the same number every time. So since it's geometric, I'm multiplying by r over and over again. So we're going to write an equation modeling this. We started at -1. I multiplied by r 3 times, so I multiplied by r to the 3rd, and I ended up at 64. So I'm going to solve this. So I'm going to divide by -1. So I get -64. And so I'm trying to do the 3rd power here. You might be concerned about a radical with a negative inside, but remember, if it's an odd numbered radical, it's okay to have a negative in there. It just means our answer is going to be negative. So let's deal with 64 as a factor tree. Maybe you're not sure, hopefully you at least know it's divisible by 2. So we can go 2 and 32. And 2 can go to 2 and 16. Maybe 16, now we jump to like 4 and 4. Doesn't matter what order you break these down, and we'll get the same, we should get the same number of 2's, no matter which way you do it. It's a 3rd root, so I'm looking for 3 of a kinds. So I'm going to circle 3 of a kinds. There's a 3, or a set of 2's, and then I have another 3 of a kind, 3 more 2's. There were 6 2's total. So 2 sets with nothing left over. My answer is negative because there's a negative inside there. I get to pull 2 out twice, so that's a total of 4. There was nothing left, so it's just -4. R is -4. That means that from one term to the next, I'm multiplying by -4. So now that I know that, I can go back and find the missing terms. So -1, if I multiply that by -4, -1 times -4 is +4. If you multiply that by -4, you get -16. And then you multiply it by -4, it gives you the 64. So those were the 2 missing terms, 4 and -16. Now, sum of the series, we have a new formula since it's a geometric series. So we use this formula, and we need to know a sub 1, r, and n. Look at number 11, a sub 1, r, and n. We know them all, so you just plug them in. So the n is 9. So the sum of these 9 terms is equal to 16 minus 16 times r, which is 0.5, to the power of 9. Put that over 1 minus 0.5. I'll type that whole thing in the calculator all at once. Just be careful. Make sure you do parentheses around the numerator, parentheses around the denominator. Now, pull out the calculator. Let's type it in. Parentheses. 16 minus 16 times 0.5 to the power of 9. Get out of the exponent, close the parentheses. I'm done with the numerator. Divide. Now parentheses for the denominator. 1 minus 0.5. Parentheses, close them. We get an answer. So 31.9375. Number 12. So we know a sub 1. This time we know a sub n and we know r. So we don't know what n is. We need to figure out what n is. So to figure out what n is, I'm going to go back. Remember this formula we put at the top of number 8. We're going to apply that formula down here. I know what a sub n is. It's negative 162 equals. I know what a sub 1 is. It's negative 2 times r. We know what r is. It's negative 3 to the power of n minus 1. This becomes kind of, let's see, at this point, hold on before I get too much further. This becomes not a very nice problem. What I would actually be able to do instead is there's an alternative formula we could use. It's probably going to make this problem easier instead of going any further with this problem. Hold on just a second. Okay, so we could take a sub 1 minus, a sub 1 minus a sub n times r divided by 1 minus r. So there's the alternative, the other option for a formula. And it looks like this one's probably going to be easier in this case because we know what a sub n is. So let me go back and erase what I started doing. We could have done it. But instead, let me show you this formula. This formula makes it a lot easier because we know what a sub 1 is, we know what a sub n is, we know what r is. We can just plug them all into this formula. I don't know what n is for my subscript, but that's okay. So this formula allows me to not need to know it. So negative 2 minus negative 162 times r, which is negative 3, all over 1 minus negative 3. So I'm going to do a set of parentheses around the top and a set of parentheses around the bottom. Okay, let's pull the calculator in for that. Negative 2 minus negative 162 times negative 3. Close the parentheses because I'm done with the numerator. Divide by a new set of parentheses. 1 minus negative 3. Close the parentheses because I'm done with the denominator. I get an answer of negative 122. So that formula is pretty nice because I didn't even have to find out how many terms there were, and I still know what the sum is. That's a nice shortcut for that problem. All right, thanks for watching.